At times, researchers will make 2 observations on one subject or make 1 observation on 2 subjects. This is called paired data. For example, let's say an experiment is conducted to study the effects of a new migraine pain reliever. Candidates at random took medication A or medication B, which is a placebo, for a week-long period, and then switched to the other medication for a week. At the end of each week, the candidates took a survey that asked them to rank their migraine pain. In this study, we have a set of paired data, one for medication A and one for the placebo, medication B. And the way we would handle this is by finding the difference between the data. In other words, take the placebo and subtract medication A from it, and then use that to conduct our significance test. When we work with population means, we know that the sample size affects the data. There are 3 factors that need to be considered for a sample size in a test. First is the significance level. The smaller the significance level, the larger the sample size must be. Consider the type 1 error and its risk. If a type 1 error is serious, then 1/100th or 1% significance level would be ideal. Consider the type 2 error and its risk. A higher significance level would decrease the type 2 error probability and increase the power. The second condition that needs to be considered for a sample size in a test is the effect size. How large a difference between the actual parameter and null parameter needs to be detected. With any test, detecting a small difference between the parameters requires a larger sample than detecting a large difference. The third factor to be considered for a sample size in a test is the desired power. How strong is the likelihood that the study will detect a difference in the parameters that is desired? And a higher power requires a larger sample size, but provides a better chance of detecting a difference in the parameters when one really does exist.